Hello, it's 1:55. As we all know, this is the time when your circadian rhythms push your body into the most alert state, ready to learn about Kafka. So if you're here to learn about Apache Kafka and Confluent Cloud, the managed Kafka service on GCP, you're in the right place. If you are here to learn about stream analytics and ingestion and delivery of event streams to real-time applications, you're also in the right place. If you're not here for any of these things, you're also in the right place, because surely these topics will become important for your organization sooner than later. My name is Kir. I'm a product manager in Google Cloud Platform, and I work on stream ingestion and delivery. This means that I spend my day working with users of Google Cloud PubSub, our native ingestion and delivery service, and users of Kafka, the open source event ingestion and delivery system. And today I'm finally able to extend a proper welcome to the Kafka users to GCP, now that we have a managed service to talk about. Now this has been a long time coming. I try. Thank you for those snickers. See, now I don't have to ask you to raise your hands if you run Kafka in production or not. And for everyone else, no worries, I'll catch you up in a second. And apologies for the bad joke. So here's how we'll do this. I will spend a few minutes setting the stage. I will talk about what we mean by stream ingestion and delivery, what companies do with stream ingestion and delivery systems. We'll talk about application patterns. And I will answer the question of when does it make sense to use Kafka on GCP, even though we have a native service. And then I will do my real job and get out of the way of the engineers and have Boyge Svingen come on stage. Boyge is a director of engineering at the New York Times, who has put a Kafka cluster on the way of every single piece of published content in this large media company. He'll tell us why, what they did for his company, and the cost of running Kafka in that critical role. And once we've gotten through that, Gwen Shapira, the senior architect from Confluent and a longtime Kafka advocate, will come and share Confluent's vision for what happens when Kafka and the entire ecosystem of Kafka tools are easily accessible within an organization. And she will give you the demo as well. So let's get into it. Streams of events everywhere. We're getting increasingly good at capturing interactions with devices, digitizing them. So this is no secret. And as engineers, we're increasingly often challenged with turning these streams of events into useful features, useful, interesting, entertaining things for our users. So for example, in gaming and media, we're using in-session user activity to adjust gameplay as the users play. We're adjusting content based on browsing history, and we're certainly adjusting the advertisements as they show up. Now, in e-commerce, well, first of all, if you're in e-commerce, you already also are in the e-commerce and media business, but you're also building recommendation systems, right? And so the recommendations that you show me on page 2 had better know what I just did on page 1 15 seconds ago. In finance, this has, of course, been a long-standing problem where, let's say, the risk group needs to aggregate events that are trades in various departments of a bank, as well as all the market activity that's happening outside. So, what's new is the sheer scale. Now, it used to be. So people say maybe 20 years ago you could have a very successful large business with a 1,000-person call center generating 100 events per second. And your messaging middleware kept up with that, and things were great. Zoom to now, and I'm routinely speaking to customers of GCP, ingesting thousands, hundreds of thousands, millions of events a second, and doing something useful with them in real time. So what we need is not just messaging middleware, but a high-throughput ingestion and delivery system for streams of events to make sense of all this. And of course, Kafka is sort of become the de facto standard of this kind of system in the open source community. So I wanted to take a couple minutes to just walk you through some of the kind of prototypical patterns that I see when I talk to users of Kafka in Cloud PubSub on an example of a sort of a hypothetical e-commerce business that got its hands on a high-throughput ingestion and delivery system for streams of events. So the journey usually starts with collecting user interaction events for analysis. If you're going to create a useful experience for your customers, you need to have your analysts and data scientists go to the warehouse and actually figure out what's working. And so the way we build this is I'm shopping for shorts and flip-flops, so I'm viewing the shorts page on my mobile device. I tap on the shorts. That generates a request to a stateless front end. That front end is stateless because it's able to take advantage of a high throughput event ingestion API to persist the event. It just publishes it right through, no longer has to worry about writing it to disk, no longer has to worry about writing it to the database, returns to the user. On the other side, now we use the delivery side of the API to start building processing pipelines. So we'll start with the data flow pipeline that just grabs the events, parses them, turns them into structured data, puts them in the warehouse, so BigQuery. Of course, soon enough, you realize that you don't actually need all the data. You need some aggregates or filtering. So you just keep adding these pipelines as you understand what you need. The beautiful thing is your front ends are stateless. Your backends you can add your backends whenever you wish, because in the middle there's this thing that is able to scale with the throughput and decouple the two systems. So once you've done this, your data scientists make their first discovery, and you're ready to create your first feedback loop. They discover that users tend to buy things they've seen before. And so what we want to build is a simple feature where when I'm browsing for shorts, I want to see the history of all the shorts that I've seen before, right? Just a strip of my user history. So we will build a recently viewed service. Every time a request comes in for a product page, the front ends reach into the service with a user profile and get back a list of products I've browsed. Perfect. Very simple. The question is, how do we populate the user history? And that's simple as well, just another data flow pipeline. A browsing event comes in, a page view, you grab the user ID, product ID, stuff it into Bigtable. Now you have a profile. So this is working, your revenue is going up, you're happy, your boss is happy, you're ready to take the next step, which will illustrate another kind of common pattern, which is handling events that are just changes in a database. All right, we're doing change data capture. And so the goal now is to capture changes in a database of an existing service and materialize them in something else. So what we want to do now is build an experience where when I'm browsing for shorts, I get a recommendation for flip-flops because they're relevant, not my browsing history. Right? So we build a you might like this service that has a product graph. You give it a product ID, it gives you other product IDs. We don't get this from the customer's activity stream, but we might have an inventory management service or some other similar system that your buyers use to sort of select and onboard products to your e-commerce store. And they're writing content. They're maybe saying this comes in such and such color, it's a such and such brand. This is starting to look like useful data that you can use to build a product graph. Except that the database is provisioned for your buyers, right? These are the 10 people who are responsible for what products are sold, not the million end users you have. So to deal with that problem, we capture the change stream from the product database, turn it into events, and from there we can build any number of materialized views of that, such as the product graph. So these are the common patterns. Now, out of habit, I've been showing you GCP hexagons, Cloud PubSub, my first product at Google, so forgive me. But of course, in reality, Kafka does all of these things, and increasingly, not just ingestion and delivery, but also stream processing with K-streams and K-SQL. So the question is, why would you want to use Kafka on GCP, and would you? Well, it turns out that the answer to this question is there are at least 3 reasons why you would. And there are many others, but it turns out to be often the right choice. So reason number 1 is easy migration. You're rarely migrating to cloud because you're unhappy with your Kafka cluster. You're probably migrating because you want to change your warehouse, or maybe you want to take advantage of Google Kubernetes Engine to run your application front ends. Kafka will migrate happily and live in cloud. So no reason to change what doesn't need to be changed. Second is, if you take a step back, when you start migrating, you're probably building a hybrid environment. Maybe that's part of your sort of long-term migration strategy. Maybe that's the end state where you want to land. And so in this case, you want your data exchange and access layer to be something that works both on premises and across public clouds. So a native service like Cloud PubSub is not the natural solution in this case. And as you will see, Kafka and Confluent Cloud in particular are very good at this problem. And then finally, if you're doing event sourcing, this Kafka is absolutely the right starting place. Event sourcing takes advantage of Kafka's particular way of doing event ingestion and delivery, it's a complete log, right? It allows you to store events as they come in an append-only log and then serve them out in order. When you have a complete log that you can read with high throughput many, many times over, you can use it to store the set of changes to a state or a database, and then materialize that database as many times as you want without putting load on your source database. As you might do if you, for example, were experimenting with something that takes a lot of different materializations like an Elasticsearch cluster. So, event sourcing, hybrid systems, and quick migrations are 3 very good reasons to start with Kafka on GCP. Of course, as you succeed, now you have a problem. You have to run Kafka well. Running Kafka well turns out to be hard, as really any system. But I'm a product manager. Remember, I don't get to run anything in production. They don't let me. What I do get to do is I do get to meet people who do. So I'd like to invite Borge to tell you his experience running Kafka at the New York Times.
So thank you. So what we're using Kafka for at the Times is making published content available to our readers. And this is what that looks like. So we have a blog post out that describes how that actually works. So I'm not going to go into detail on that now, only to say that this is an example of event sourcing, or specifically a log-based architecture. So the core principle in this is that we maintain a log of every asset published by the New York Times since the beginning of 1851 and up until events being published in real time and now, I hope, since we're all here this week. There are 2 main principles for running such a log. We need two main requirements. We need ordered playback because the published events we are writing to the log have causal relationships between them, so the ordering matters. And the other thing is that we need infinite retention. We want this to be available forever. And only Kafka fulfill both of those requirements. Now, because Kafka is such a critical piece of our infrastructure, the news don't get out here if our Kafka cluster is down, and that's a very big deal at the Times. So because of that, we put a lot of work of effort into keeping this Kafka cluster available and reliable. So we have a dedicated team of engineers running it. And more concretely, we're running this on GCE. We might have chosen GKE if we had started over now. We have an Ansible script that handles all our Kafka deployments and rolling updates and all of that. We have set up multi-region replication using Mirror Maker, so everything published to one Kafka cluster, it becomes available everywhere. Latency is very important to us since this is news. So we also have implemented our own log offset monitor that lets us know if one of these log consumers fall behind. And we're also taking full advantage of Kafka's ACLs, specifically to limit writes, because anything being written to this Kafka cluster goes directly onto the site. So we have to keep very tight control on who gets to write to it. In addition to all of this, we're also very conservative in how we use the cluster. So for instance, we don't allow other teams at the times to use this Kafka cluster for their own things. And as a consequence of that, using things like Kafka Streams, KSQL, and Kafka Connect is a lot harder than we would want it to be. And in spite of all of this, things still sometimes go wrong. So Kafka is highly available in the sense that if a broker goes down, things are still fine. But when all the brokers are logging excessively and run out of disk at the same time, that doesn't really help. It also didn't help us when we configured mutual SSL authentication, and all communication between our Kafka brokers stopped very suddenly, which also brought the entire cluster down. Maybe the most frightening case we've seen was when one of our consumers had its offset reset and immediately started creating a version of the New York Times homepage with old news, which is really not something we want. Luckily, we managed to stop that before it got to the reader, but we do remember that day. And basically, as a technology strategy at the times, we want to run managed services whenever we can. It's not, we want to be good at news. We don't want to be good at running infrastructure. And the reason we run our own Kafka at all and put in all the time and resources and attention to that is because when we started this project 2 years ago, there was no managed Kafka on GCP, as I had long discussions with Kir about. Gwen?
So some people want to be good at news and not at running Kafka. We, on the other hand, at Confluent, are kind of crappy at news. On the other hand, we're very, very good at running Kafka. We've been running Kafka in production, our team, since the first lines of code for Kafka were ever written at LinkedIn. About a year and change ago, we announced Confluent Cloud as a way to let us manage your Kafka in the public cloud. Now, in order to really see the value of what we're doing here, I want to take you a few years back to the days where Kafka was still first invented at LinkedIn. 10 years ago, we started seeing the microservices trend. And the more microservices we had, the more databases each microservice had, the more lines of communication going back and forth between microservices and database. Our entire infrastructure became very complex, very hard to manage. Now, this talk is not about simplifying the complexity of IT, even though that's a good topic of discussion. It's about how Kafka can help here and really simplify your architecture. So you have, when you run Apache Kafka, you can now have connections between the different applications. And Kafka, every event that is published to Kafka is available to everything. And this obviously greatly simplifies. You build these centralized architectures that allows you to deploy new services and gives them access very easily to all the data that your organization has at scale in a very reliable distributed system. Now, of course, the messy infrastructure, once we started doing cloud migrations and hybrid cloud, it did not get any better. In fact, it got a lot worse. We took the mess that we had in one data center, and now we have a mess in 5 data centers, and in this cloud provider, and in the other cloud provider. And now that it's going on public clouds, it has real costs, and it has real security risk. So the mess just got a lot more expensive. So think about the same architectures that simplified our microservices deployment on-prem, now applied for both cloud migration and in the cloud. It really allows you to have one channel of communication to secure. Each event is replicated once, which drives down costs, and you have this nice, much easier to manage and monitor architecture out there. But that's not it. Because you have all the data available in Kafka for streams, you can start experimenting with everything the clouds have to offer. You want to try data flow, you want to try TensorFlow, you want to try BigQuery. Even if you never did it before, you're totally a MySQL shop, very easy to just stream events from Kafka to BigQuery and run an experiment. So you really have a lot more possibility out there. And this is really the vision that inspired Apache Kafka. Connect everything to everything, from on-prem to the cloud, microservices and databases, and make all the data available to the entire organization, kind of breaking down all those silos vision. But when building a platform, it's not just about the platform itself. That's a lesson that we all learned from eBay. You build a platform to sell stuff, but the point is the stuff you actually sell. The power of this centralized platform is from the things that connect to the platform, that bring in the data and take out the create value to the business. The value is really in the microservices and the ecosystem. So Confluent includes a lot of components that makes it very easy to create those very lively ecosystems that make data available for your organization. One of the coolest ones is schema registry, which allows you to make changes to the schema of the events, to the data that you're transmitting, independently between the producer of the data and the consumer. So the producer wants to make some changes, and you can do it in a very safe ways. Agile is all about making change and evolution safe. Another cool tool is KSQL. I think Borge mentioned it. It allows you to create stream processing applications using a very familiar SQL-like language. We also have clients in pretty much every language. You're seeing like 8 here. There's like 50 of them that you can use. If you like PHP, here you go, Kafka PHP clients. That's kind of the power of open source, is that once you have an open protocol, everyone can create clients. You're not depending on anyone to do it for you. Now, we mentioned databases, and integrating microservices and databases is really what allows you to run your entire organization off one stream of events. Kafka has the Kafka Connect infrastructure, and Kafka Connect allows you to plug in connectors. And we have 100+ connectors allowing you to get data from different databases into Kafka, from Kafka to other databases, from Kafka to another Kafka. If you want data from Vertica to show up in BigQuery, people actually do it. You have a Vertica connector getting data one way, BigQuery connector the other way, and you are good to go. This is incredibly powerful, especially since it requires almost no coding, and we run it for you. So that's the whole thing, right? You want to use it, you want to gather your data, you want to build your microservices, you don't want to actually run any of it. And the reason you don't want to run any of it is that Kafka is a distributed system, and running distributed systems is difficult. We should know, writing distributed systems was difficult enough in the first place. It's kind of tricky, but as we all know, debugging is twice as hard as coding. You're not allowed to be as smart as humanly possible while coding, because you need to be twice as smart while debugging something. Race conditions and scheduler timing, all this has been a thorn of our side for a very long time. Now operations is all the fun of debugging with time pressure, customers yelling at you, money ticking away. What can be more fun? So I want to just share with you 3 kind of reasons that it's a good idea to let someone else run Kafka for you. The first is that random stuff happens. And random stuff is usually not that good stuff. There's the failures that we expect to see. We kind of know that disks will fail, and machines may fail, and the network will have issues. Those we plan for. People who forget to renew their SSL certificates, not so much planned for. But the thing is that when you have a strong team and you build a strong system that is capable of overcoming failures, you have the experience and you have the tools and you have the monitoring in place, you can build very resilient systems. The trick is that it requires experience and expertise. You can build it in-house. A lot of people do. Borge has an amazing team that manages to build something very resilient. But as you said, it may not be your business to do that. Even when nothing absolutely fails, you still have to make changes to the system. You can't just say, it works today, let's not touch it ever again, because even though there is a risk of change, every upgrade has a risk of new bugs and things going wrong, there is also a risk of not changing, right? We know that if you don't evolve and adapt, you'll be left behind. New features actually have value. They allow you to implement things faster. Some people are kind of sad that they cannot use KSQL because they know that it will allow them to move faster and deliver value faster. Why not offload the risk to someone who is being paid to take this risk and go on your way? You get the benefits. And this is really the key. You focus on your ideas, we focus on running Kafka, and everything will be amazing. So I want to jump into a demo, kind of semi-live demo, where I show you how I actually build one of the architectures that Kir mentioned, streaming data and joining it and doing some processing to it, using Confluent Cloud on multiple clouds. So it will be a hybrid cloud demo. OK, so you can see here, I have 2 clusters in Confluent Cloud. This is the Confluent Cloud UI. You can see I have AWS and GCP. I'm going to move data between them. You can see how big my clusters are. Huge, right? OK, those are demo clusters. I want to create a new cluster. I can choose a name, and then I can choose how large or small the cluster is going to be, which cloud it's going to be on. And you can see that as I change my cluster configuration, the pricing on the right kind of automatically adjusts to reflect my new cluster. If you pay a lot of attention, you can see that GCP is slightly cheaper than the competitors. Once I'm happy with the configuration, you can see that if I want more storage, it's going to be slightly more expensive than cases where I want less storage. I find the configuration, I'm happy with the price, I'm happy with my setup. I go in this case, I'm canceling. And let's see how you manage those clusters that I now got. So you can see here, this is the list of topics that I already have in my GCP cluster. And then if I go to AWS, you can see the list of topics that I have in AWS cluster. And suppose that I want to see what is in the topic. I can look at the schema. I mentioned the schema registry, and that allows me to keep compatibility. You can see that in this topic, I have users, and you have the usual suspect fields. I have user ID, and region, and gender, and kind of the stuff I want to know about those users. Now, suppose that I have those users in AWS, and maybe they arrived from something that dumps data in S3. I also have maybe some page views. I have a bunch of stuff running on AWS. But I really want to process it on GCP, because GCP has things like TensorFlow and BigQuery, a lot of stuff that I really enjoy using. Like, as a developer, you always have your favorite tools, and some of them happen to be in GCP. Getting data from cloud to cloud is actually a hard problem. This is something that you'd think is going to be easy until you basically go and try to do it, and you figure out that if all you know is the stuff within your cloud, they're not going to help you move anywhere else. Confluent Replicator, that is based on Kafka Connect, basically allows you to copy some data. So you go into Kafka Connect, and you choose what topics you want to copy. So you can have a white list, a black list, maybe everything except the test topics, a regular expression. You can basically type in the topics that you want to copy. And then you can see a bit down, you have where does the data come from? In this case, it comes from AWS. And a bit further down, it's going a lot of security configs, and it's going to be where's the data going to? It's going to GCP. Once I'm happy with one more configuration to talk through, I can rename the topics. So I can say that the topic was used to be called aws.users. I want to rename it to start with GCP. So it will kind of make a bit more sense. I'll know where the data came from, where it went to, what is the topic. Those hierarchical topic names are kind of common. Once I'm happy with the config, I just go ahead, start this connector or replicator. And let's go and see the topics in GCP. So here we go, as we did the rename. So it's gcp.aws.users. Now, the first thing I want to check is that my schema arrived intact, that my data is more or less the way I expect it to be. So I go in and say browse schema once again. And you kind of see, yep, looks the same. I have the region, the gender, everything that I expected. Now let's go back and see what is the data actually like. So we go to a different topic. Remember, I replicated 2 topics, the page views and my users. let's go to the page views and use KSQL to see what is the data in my topic. So I do query using KSQL, and it's the first thing I have to do is create a stream, which is basically a materialized view on top of the topic. I have one already existing, so no big deal. And once I go in, you can see it's very simple. I do select star, run the query. Behind the scenes, it starts a stream processing job, a consumer, and pretty soon you'll see a stream of events on screen. And this is a live stream of events. You can see the user ID and the page the user is viewing. You can see the timestamp. And as data keeps coming into the topic, you can see that I have more and more events to go through. You can see this is a pretty busy topic, so you can see that we're accumulating more and more events in there. Now, this is kind of a simple query. Suppose that I want a subset of the events. Suppose that I want only page views from a single gender in the audience. Well, the page view topic does not have anything about gender, but it has user ID. And the user topic has the gender of each user. So I can join those two streams of events and then do a filter based on the other field. Very normal thing. This is a continuous query. So it's a query that basically does an ETL job that runs all the time. The results go into a new topic. Now, what do I do with results that go in a new topic? Well, I may want to analyze them. That's why I ended up in GCP in order to analyze it. So what I want to do is take those events, dump them into, say, BigQuery, and now the sky's the limit, right? You can use Google Data Studio, and there's tons of tools. So I go again to Kafka Connect and create a sync connector that uses Google BigQuery as a connector. So I pick the topic, the subset of page views that I already created. I pick the BigQuery connector. I give it a name, say Google BigQuery. And then I start configuring this topic. And you can see that those are the normal, if you use BigQuery, those are configurations should be super familiar. Which tables do I want the topics to go into? What is the project? What are the views? All those things that I've already used to sing. Once I'm happy with my configuration, I click OK, and I'm done. And think about it. This was a 7-minute demo. We got data out of AWS into GCP, queried it, created a continuous transformation, and dumped the data into BigQuery into further analysis. So this is kind of if I may say so myself, kind of a big deal. It used to be incredibly difficult because I know I've been trying to do it for a pretty long time. So this is really part of the value of having an open source, open standard software, is that you are not locked into a vendor. You can deploy and have the same experience in every cloud, and you can easily move between the clouds. Now, if you remember two things from this presentation. The first is that streaming platform gives a lot of value to the business, and data sharing gives a lot of value to the business, but it really takes an ecosystem of tools that exists around Apache Kafka. You cannot do it with just a messaging system. You need a lot more than that. And that if you don't want to go through the pain of having to learn how to manage it yourself, which takes a while, you may want to run Confluent Cloud on public cloud of your choice. Hey, GCP is a nice one, and make us do it for you. Now, in order to go home and try it yourself, Confluent Cloud arrives in two flavors. Confluent Cloud Enterprise means that you have to call a salesperson and talk to them. This is our unlimited scale, enterprise level. We have SLAs, we have support, we have VPC peering, you have security options. When Borge wants to move into Confluent Cloud, willing that maybe he'll choose to do it, this is probably the options that he will use. Now, if you are a team of developers who want to experiment with Kafka, you don't need huge clusters, you don't need tons of support, you just want to try a bunch of stuff, create a lot of clusters, pretty much what I did here in the demo, just spin up a bunch of clusters and try stuff out. Confluent Cloud Professional is the tool for you and your team. So I hope you'll all run home, and I'll basically look at our dashboard and see this uptick in Confluent Cloud Professional users because you're all trying it. That's it. We'll still be around for the rest of the event, I guess. So if you want to catch us with extra questions that you're shy to ask in public, we'll be super happy. Confluent has a booth down on Moscone South if you want to catch some of our cloud experts who are going to be around.
Thank you all for coming.